In this lesson, we're going to talk about dilations. Dilations are transformations where the pre-image, the original shape, and the image are similar. Now, here's something we haven't talked about in class is what similar means. We talked about congruent. So similar means they're going to have the same shape. So a triangle remains a triangle. The angles of that triangle will remain the same, but the side lengths are going to change. So really the only thing that changes with dilations are the lengths of the sides of the particular shape that we're dilating. So keep that in mind. So a square will remain a square, the side lengths will change. So the only thing that changes is the side lengths. There's two types of dilations. We're going to do a reduction and we'll have enlargements. So reduction means to make smaller. We're going to talk about this term called scale factor, and that's when it's between 0 and 1. A scale factor of 1 keeps the shape the same. A scale factor of 0 we can't have. So if it's less than 1, it'll be something that makes it smaller. So an example would be a scale factor of half. So whatever the shape is, it would be shrunken in half. So as a quick example to illustrate that point. Enlargements are going to be greater than 1, and this can be pretty big. Typically, because we're using graphs, the enlargements scale factors will be 2 or 3, maybe 4, but usually 2 or 3 are the values. And what that means is that the original shape will be doubled or tripled in size. Okay, so let's take a peek here. So scale factor that we just talked about is the new length divided by the original length. So let's look at an example of how this works. So in this particular shape, we need to look for the primes. Okay, so in this case, the primes are going to be out here. So in this case, we have an enlargement because the image is bigger than the original. So if this length is 2 on the original, right, and this length is 4, we have 4 divided by 2, which gives us a scale factor of 2. Now over here are the primes. And so because the original is smaller than, is bigger than the image, it shrinks down. So somehow they come up with a scale factor of 1/4 without numbers on here. But that would be, as an example, if this were 4, if this were length of 4, and this were length of 1, the scale factor would be 1/4 because it's new, which is 1, divided by the original, which is 4, so 1/4. Okay, so let's take a look at this. So again, how do we know where we start? We start where there's no prime. So this is the original. So we know that we're going to have an enlargement. So the question is, this is 4. That's the original length, and that's going to go on the bottom of our calculation. The new length is 4 plus 8, which is 12. So in this case, right, we just talked about what is new because it has primes. And we end up with a scale factor of 12 divided by 4, which is 3. Okay? So here's 3 types of problems. We're given new and old, and they want you to find the scale factor. You're given old or the original in a scale factor, and they want you to find the new. Okay? And then we're given the new and then a scale factor, and they want you to find the original. So we'll talk about this in a second. Let's look really quick at this example, and we'll get into more of this. So in this problem here, we have an a reduction because of the image is smaller than the original. Okay. So here's an example where probably the easiest thing to look at is the straight lines here. So in this case, the new, which is 2, we would divide by the original, which is 4. So 2 divided by 4 is 1/2. So this would be a reduction with a scale factor of 1/2. Okay. Now, if we didn't have straight lines, let's take a look at this. So the original on a slanted line would be up 1, 2, 3, 4, and over 2. So this particular slope would have a slope of 4 up and 2 right. So this slope is 2 up and 1 right. And so if we had 4 over 2 and 2 over 1, we see that the slope was reduced in half. So even if there's no straight line, we can still get the scale factor by figuring out the slope of each of the segments, but because this is 1/2, all of these also have to be 1/2 as well. So you only really need to do one side of it to figure out a scale factor. Again, if the straight side length is given to you, then that would be ideal. But if not, you can still do it using diagonal lines. All right, go back here, 3 types of problems. So we're given new and old, and you want to find the scale factor. That's what we had up here. We're given new and original, and we want to find the scale factor. But now, because in this component there's 3 parts, we can also be given the original and the scale factor to find the new. And in this case, what we do is you take the coordinate and multiply it by the scale factor. We're going to show you an example of that in a second. Over here, if you're given the new and the scale factor, and you want to find the original, you divide the point by the scale factor. Okay, so make sure you have this written down in your notes so that you're aware of this is what we do when we're given these situations. Okay, so here's a case where we're given vertices right here, which we graphed. Okay, we're going to use multiplication to find the image. That means the new, right? It's centered at the origin. So for today's lesson, everything's centered at the origin. And it's a scale factor of half. So what we do is we multiply the coordinates by half, right? So in this case, 2, 0, that would become 1, 0. Negative 1 times half would be negative half. 1/2 times half is 1/4. 1 times half is a half. Negative 2 times a half is negative 1. So when we multiply these by 1/2, we get our image coordinates in which we graph. Now here's something to keep in mind. Because we're centered at the origin, what this actually means is that we can draw lines straight through the image points. So as this dilates, the dilation will occur on the lines from the origin through the original points. So if you graph from the origin to the original point, the dilation will occur. I'll show you some more examples of this, and I think you'll start to see it more clearly. So here's a case where we have these 3 points graphed. Okay, so remember we talked about this as the origin is the center of the dilation. Now we're going to have a scale factor of 2. So what we do in this case is multiply the coordinates times 2. So these 2 values times 2 would give you negative 10, 2. These 2 values times 2 would give you negative 6, 8. These 2 values times 2 would give you 4, negative 2. Then we graph them, and what you notice is that these points would end up on the green lines that I drew. So the dilations occur on those green lines. So again, from the origin through the original, the dilations are going to occur on those lines. This becomes really important in another future lesson where we use this idea as well. All right, here's another one where we have a triangle graphed. Now in this case, we're still going to use this idea where we can draw lines through the original coordinates. Now we know the dilation is going to occur on those green lines. So in this case, we have a scale factor of 3/4. So we can use the ND button, put 3 over 4, and then multiply it by the coordinates. And you'll end up with these coordinate values as the image points. So when we graph them, this is what we end up getting as a graph. And again, notice where the image points are when we graph them. They end up on those green lines. Now, I don't have it drawn in, but you definitely want to make sure that you have your triangles drawn in as well.